So what I'm doing here is demonstrating zero dimension represented by a point in space. I use red because it shows up better. But this is an example of zero dimension. It's not exactly how big that point is. The point just represents the point in space and time. So now I want to talk about going from zero dimension to first dimension. And the way that you do that is you add another point. You're trying to put them in the same place at the same time. So if you put one point in one spot, one point in another spot, the shortest distance between those 2 points is a straight line. So that straight line represents first dimension. So no matter if you put it up 80 degrees or 30 degrees from it, no matter where that point is, wherever you put that other point, it's always going to make a straight line. No matter if you put it up, down, behind it, below it, it doesn't matter. If it's only 2 points, when you connect those 2 points, it's going to make a straight line. So now for second dimension. Second dimension is putting two lines in the same place. And the way you would do that is that you would intersect those lines. And when you intersect the lines, you get a plane, which I'm trying to demonstrate here by using the paper. You can see it's a flat surface. You can't necessarily go around it. You can go around the paper, but those two line segments represent a plane. So now we're going to talk about 3D. 3D is a three-dimensional object, and what I try to do with the paper is I try to fold it to make like a square, but it didn't work out so well. But basically what you're doing is you're intersecting two planes together to make them be in the same place at the same time. And when you do that, you get a three-dimensional object, such as this right here. Three-dimension means that you can walk around it, you can walk underneath of it, you can pick it up, but more than likely has mass to it. So when you say 3D, pretty much everybody knows what you're talking about when you say 3D. So now the fourth dimension is time. And how do we put two three-dimensional objects in the same place? It's going to be time. Now my book is still there only 2 seconds ago. Now my hat is there. Now the book is there again. But the hat is still there only 2 seconds ago. And then I can put my hat back there. And then the book is still there only 2 seconds ago. So what's separating them is time. And then while we're at it, we'll do that white remote is there when the hat and the book are still there only a few seconds ago. Now the black remote is there. And then while we're at it too, the only thing separating the black remote and the white remote from being there instead of the hat and the book is the probability of me picking the white remote and the black remote, or the book and the hat. So the only thing separating them is the probability of me picking these two objects or the other two objects that I started out with.